Okay, today's lesson is 2-1 Part A of Power and Radical Functions, and we are going to concentrate on graphing and analyzing power functions. Now, to speed up the video, I already have the graphs there, but I'm going to talk about the characteristics that you need to remember of them in case you have some kind of matching feature later on or have to graph them. So, a power function basically is any function in the form of ax to the n, where a and n are non-zero constant real numbers. Okay, so if you want to, it's hard to see in this area, so that's basically what it looks like. Okay, there's no adding or subtracting in it whatsoever, and n is going to be a real number. Okay, that's basically everything you know thus far. So what we're going to deal with first are what you had in Algebra 2, and that was if n is even. Okay, if that exponent is even, then as you can see from both of these graphs here, that the arrows are pointing the same way. If it's positive, the arrows are pointing up, and if it's negative, the arrows are pointing down. Okay, now that means that they're going to have very similar characteristics. For example, I have an arrow on both sides of my graph, so my domain is all real numbers, or negative infinity to positive infinity. My range is limited. It doesn't go below the origin. So in this case, I'm going from the origin, or 0 to infinity. But when it's flipped upside down, you always give the smaller number first when you give an interval notation. So I'm going to have negative infinity to 0. And I have a bracket because it includes that point 0, 0. Okay? X and Y intercept. Where does it cross the x-axis and the y-axis? Well, that happens to be the same spot on these, and that's 0, 0. You can trace this whole graph. When we talk about continuity, you had that a lot in the previous chapter. Okay, you can trace this graph from arrow to arrow, from one end of the graph to the other, without picking up your pencil in both cases. So it is continuous on the interval, all real numbers, or negative infinity to positive infinity. Both of them are. Okay, symmetry. You can fold it along the y-axis, and it matches on both sides. So it has y-axis symmetry. The minimum value here is at 0. The maximum value for it being negative is at 0 also. Okay, now decreasing and increasing. Okay, again, we talked about that a lot. So when you trace, you always have to start on the left side. And when you're tracing, I am decreasing from here all the way until that minimum point. So that means I'm decreasing from the left arrow, which is negative infinity to 0. And then I'm increasing from 0 to infinity. And it's never occurring at the point, so these answers are always parentheses, y'all. Okay? And if I trace this graph, starting at the left, then I'm increasing before I'm decreasing. So however you wish to do it, I'm increasing from negative infinity to 0 and decreasing from 0 to infinity. Okay? In behavior, all right, we have a left arrow and we have a right arrow. I put it over there. Okay, the left arrow, because that says as x approaches negative infinity. As x approaches negative infinity, what is my arrow doing? It's going up to positive infinity. Okay, and then as I go, what's the right arrow doing? Because that's what it says when it says x is approaching infinity. What's the right arrow doing? And that one is going to positive infinity as well. So on your even functions, these two are the same. So what's going to be on when n is negative, not n, a is negative, excuse me, then my left arrow and my right arrow are still doing the same, but this time they're going to be going to negative infinity. Okay, so even, okay, when your integer, your exponent, when n or your exponent is an even number, your arrows have to point the same way. Okay, if they are odd, they point in different directions. Okay, odd positive, odd negative. So in this case, my domain and range are the same because I have one arrow pointing up and one pointing down. So my domain is negative infinity to positive infinity, also known as all real numbers, either one. Okay, x and y intercept, again, they're still going through 0, 0 in both of them. Continuity, there are no breaks. I can trace the whole graph from one arrow to the next without picking up my pencil. Again, all real numbers, or negative infinity to positive infinity. My symmetry, a little bit harder for people to get this one, okay? But if I rotate my graph 180 degrees, which would be taking this point and going 180 degrees, then I get that point. It matches my graph. If I start here and go 180 degrees, then I'm going to be over here, okay? So that symmetry is around the origin, okay? Extrema, there are no extrema, and that means there's max or min. We had max and min up above. We don't have any here. Increasing, okay? So this one, if I start at my left arrow, it is always increasing, never decreasing. This one is always decreasing, never increasing. Again, you have to read that from left to right, and if it's always doing it, then your interval is all real numbers or negative infinity to positive infinity. Okay, again, I have a left and a right arrow. So what is my left arrow doing? My left arrow is going down, and my right arrow is going up. And over here, it's going to be the opposite way. My left arrow is going up, and my right arrow is going down. Okay, so what are you going to have to be able to do? So for your homework, what I've set up this year is for you to, we're using Delta Math, and you'll be given the graph, and I give you the equation. So if you don't like the graph in the picture, y'all, go use Desmos or ClassCalc to put the equation in and look at it. Or if you have a TI, that's great. You either any one of those, okay? Use something to graph it if you want to look at it more closely. So you don't have to worry about the graphing this part. Analyze each function, so you're going to have to fill in the blanks. And these are the questions that you'll have to answer on your homework problems. Now, I do want to talk to you. 3x to the 6th. The key features that you're looking at, if you had to match this to a graph, 6 means it's even, so they're going in the same direction. This is a positive number. They're both going up, which is what my graph is doing. They're both going up in this case. So my domain is all real numbers or negative infinity to positive infinity. My range, it has a minimum at 0. So, and the range, y'all, is always the y value. So my lowest y value is down here on the x-axis. So it is from 0 to infinity. Intercepts, where does it intercept? At 0, 0. In behavior, okay, so same thing that we are doing with our limits. As x approaches negative infinity, the graph is going to positive infinity, and they have to be the same because it's an even exponent. Continuity, again, I can trace the whole thing. All real numbers are negative infinity to positive infinity. Increasing, so remember, we start at the left side, and I am decreasing first until I get to 0, 0, and then I'm increasing. So if you want to do that, that way you can say that's negative infinity to positive infinity, and that is 0 to infinity. And that's all you have to be able to do. All right, so I'm going to do some more examples because they're different functions as you look at them. All right, so 1b says f of x equals negative 2/3 x to the 5th, okay? So first thing I'm looking at is the fact that this is an odd number. So my arrows are in different directions. Then I'm looking at this, and it's a negative. So an odd normally goes down and then up, but since it's a negative, it does the opposite, saying that it starts going up and then goes down. So my domain and range are still the same. All real numbers, negative infinity to positive infinity. My intercept still cross at 0, 0. My end behavior, okay, the left arrow is going up, the right arrow is going down, okay? And so the key that you have to know this if you're using Delta Math is you've got to know that little thing, and then the f of x will point to it. If you use the limit notation, then it's equal. Continuity, no breaks whatsoever in my graph, so it's all real numbers, negative infinity, positive infinity, increasing or decreasing. So I'm starting at the left up here, and I'm tracing, and every time my fingers are going down. So it is never increasing and decreasing everywhere. Okay, that was 1b. So those were some nice, probably what you're used to. Then we get into the negative exponents, okay? So when you have a negative exponent, y'all, you need to think about the fact, I'm only talking about negative integers right now, and if you have a negative integer, you're going to have some type of infinite discontinuity because the negative integer, y'all, puts that in the bottom. So that's negative 1/2, and the x to the 4th is like 1 over x to the 4th. So we end up having a variable in our denominator, which we've talked about causes us to have part of our domain not acceptable. Restrictions on our domain. So it's just x, so my domain is restricted and can never be equal to 0. So we write that as negative infinity to 0, union 0 to infinity. My range, okay, if you're looking at your graph, y'all, the lowest point goes on forever and ever down here. So my lowest point is negative infinity, and my highest point is up here, but it never touches 0. So we're going to go from negative infinity to 0. Okay, x and y intercepts, it never crosses either axis. End behavior. Okay, so I'm looking at the end behavior. This one's a little bit different, y'all. What is this left arrow doing? The left arrow is over here. This is not the end behavior. This is in the middle of the graph. These are the ends of the graph. So you're looking at the left side and the right side, and both of those are getting closer and closer to 0. So that's what that is. Continuity. It is only continuous on the two intervals, not at the point 0. It is increasing. So if I start at the left, this here is decreasing. But then when I go to the next x value, then here I'm actually increasing. So however you wish to, if I started saying decreasing. So negative infinity to 0 was decreasing. And then 0 to infinity was my increasing. Okay, so that was an odd negative. Okay, odd negative. Nope, that was an even negative exponent. Let's go look at an odd negative exponent. Okay, so again, negative exponent is like putting that variable in the denominator, which is why we have infinite discontinuity again at 0. So my domain is negative infinity to 0, union 0 to infinity. My range is the same. My intercepts, again, never crosses the x or y axis. My end behavior, okay, again, I'm looking at what's happening at the left arrow and the right arrow. This right here is in the middle of the graph, not the end of the graph. So both of those, again, are going to 0. My continuity, just like my domain, negative infinity to 0, union 0 to infinity, increasing or decreasing. So I'm starting on the left side, and I follow my graph. I'm decreasing, and if I jump to this right here, then I am still decreasing. So there is never an interval where it's increasing, and it's always decreasing for my defined domain. So that's what we have. Okay, the last two examples that I have here are going into rational exponents. Now, remember, a rational number is a number that looks like a fraction, okay? And if I have an even number on the bottom, my domain will be restricted. So this first one right here, f of x equals 2x to the 3/4. Okay, so the reason, I don't know if y'all remember this, but the reason is when you have one that says x to the 3/4 or a fraction, that's like saying, if you remember how to define it, and we're going to talk about it more loosely, but that's asking you for, that was really bad, the fourth root of x to the third. And when you take the fourth root or an even root of something, y'all, you can't take an even root of a negative number. I don't know why that happened. Okay, so here's my graph. Okay, here's my y-axis right here. Okay, and that point is 0, 0 because I cannot take the fourth root of any negative number. So it's starting here and going on forever and ever in that direction. So my domain, can I take the fourth root of 0? I can, so it's 0 to infinity. My range in a bracket, because it includes that, my range is the same. My intercepts is that starting point of 0, 0. My end behavior, okay, y'all, this is a point, 0, 0. This is an arrow. So that is something you need to know about a graph, even though your graph, you might not see arrows. So you got to know something, a little bit about what you're looking at. So in this case, the limit as x approaches infinity, which is my right arrow, which is the only place I have an arrow, is going to be infinity because it is going on forever and ever that way. Okay, continuity, it is continuous over the interval of my domain because my domain was from 0 to infinity and it continues. Increasing, as I just traced that, it's increasing the whole time and it's never decreasing. And again, the increasing is always parentheses because you don't talk about the specific point. Okay, last example, 3b. So that one we had an even number on the bottom, and this one we have an odd number on the bottom. And if we have an odd number on the bottom, y'all, it does not affect our domain because I can take the cube root of a negative number. So my domain is all reals or negative infinity to positive infinity. My range, again, all reals, negative infinity or negative infinity to positive infinity. My intercepts, where does it cross my x and y axis? Well, x-axis, y-axis, it's crossing right here. So my intercepts are 0, 0. In behavior, I have a left arrow and I have a right arrow, so I have to answer both of those. The left arrow is going down and the right arrow is going up. So down to negative infinity, up to positive infinity. It is continuous over the whole interval of my domain, increasing or decreasing. So if I start at the left side, my y values are getting bigger and bigger, so I am always increasing over that same interval and never decreasing. And that is all of power functions. So if you have any questions, please don't hesitate to email us or come see us or contact us some way. Thank you so much, and y'all have a great day.